Good morning everyone. This is Mr. DHAKSHUNHAAMOORTHY, AP, AIML department. I am handling subject 22 AM 307 Advanced Java Programming in the Department of Electronics and Communication Engineering, Unit 3, Stream API and Functional Programming Paradigms. Topic 2, Terminal Operations for the class second year ECE A and B section. Terminal operations: collecting results, collect of collectors terminal method, reducing and summarizing, reduce of binary operator, comma, summary statistics method. Iterating purpose for each of consumer, matching and finding for that any match, all match, none match, find first, find any. These methods we are using. Counting purpose, count of this method. So there are 5 different terminal operations are there: collecting, reducing and summarizing, iterating, matching and finding, counting. Terminal operations are the final operations in a stream pipeline and produce a result. Emphasize that once a terminal operation is invoked, the stream pipeline is considered consumed. Discuss the role of collectors in aggregating stream elements. Terminal operations are executed at the end of the stream processing pipeline and triggers the processing of intermediate operations. Terminal operations are designed to provide results such as a single value collection or side effects after processing all the elements in the stream. Terminal operations: collecting results. Collect of collectors example. Here list string, list name is names equal to arrays dot as list of Alice, Bob and Charlie. 3 strings we are storing inside the list. String join names equal to names dot stream. Just we created a names stream. After that dot collect of collectors dot joining. Here the delimiter we are using is comma, so that each and every string is separated by comma. Collectors offers a variety of options to accumulate the results, including joining, grouping and partitioning. Mention the flexibility of the collect operation in the producing different types of results. Discuss how custom collectors can be created to perform specific tasks. Collectors provide a powerful and flexible way to perform complex data aggregation tasks in a concise manner. Terminal operations: collecting results. Collect elements to a collection. Example list, comma set. Import.java.util.list, import.java.util.stream.collectors are the 2 packages are important to execute. Dot collect method and the streams whichever we want to create. For that we required java.util.stream.collectors. Here there are 2. First of all, after including the packages, the class, public class collect example we are seeing here. The class name is collect example and main method. Inside the main method, string type list, name is names, list of Alice, Bob and Charlie. Another list is created, list string type list, and name of the list is result names dot stream. Here dot map of string colon colon to uppercase. All the names given in the list are converted into uppercase. After that, just it is collected dot collect of collectors dot to list method collects all the values, all the strings in uppercase are stored into the results. System dot out dot println of result is printing the values in uppercase. Terminal operation reducing and summarizing. Reduce binary operator. Here just list integer type list, and list name is numbers equal to arrays dot as list of 1 2 3 4 5. Int sum is equal to numbers dot stream dot reduce 0 comma integer colon colon sum. Reduce aggregates stream elements into a single result using a provided accumulator function. Explain the use of initial values, how different accumulators can produce various types of results. Mention common uses of reduce such as summing, product, and concatenation. For example of reduce without an initial value. Optional integer product equal to numbers dot stream dot reduce of a comma b implies a star b. The reduce operation is versatile and can be used to implement a wide range of aggregation operations. Reduce and summarizing. Reduce elements to a single value using an accumulator function. Here import java.util.list is the package we are adding with this program. To create a list and to manipulate some functions in the list, we are using java.util.list. And public class reduce example is a class name, and main method, inside the main method, list of integer type of list, and the list name is numbers equal to list dot of 1 comma 2 comma 3 comma 5. Int sum is equal to numbers dot stream, just numbers list is created as a stream. Dot reduce of 0 comma integer colon colon sum of the elements, and just it is printing the values. System dot out dot println statement just printing the result sum value. Terminal operation iterating. For each consumer example, list string type and the list name is names equal to arrays dot as list Alice, Bob, Charlie are the values stored inside the list. Names dot stream method helps us to create the stream. Dot for each of system dot out colon colon println method helps us to print whatever the values stored inside the list is printed by iterating arrays indexes. See, for each helps to iterate from Alice to Charlie, so that we can able to print the values. For each performs an action for each element in the stream, usually resulting in side effect. Discuss how for each differs from collect in its purpose and use cases. Mention that for each is not recommended for parallel streams due to non-deterministic behavior. Example of modifying external state with for each. Same example which I have seen in the Here the whichever seen in the beginning, here in the example, for each is typically used for executing a block of code on each element, such as printing or logging rather than collecting results. Iterating for each performs an action for each element. Here import java.util.list package we are including. Class name is for each example. Inside the main method, list string type and list name is names. List dot of John, Jane and Jack. 3 string values stored inside the names list. Names dot stream dot for each of system dot out dot println. It is just iterating into the list and printing the values one by one. Terminal operation matching and finding any match, all match, none match examples. Boolean as long names equal to names dot stream. After creating a stream dot any match, name implies name dot length method greater than 5. If the list contains any names more than 5 characters, that alone matched and that is collected and stored inside the as-lang names. If it is found, then it is telling that yes, some name values which is greater than 5 character. Any match, all match and none match are used for predicate based matching. Find first and find any, return the first or any element matching the given predicate. Predicate in the sense conditions. These operations are useful for short circuiting stream processing based on the conditions. Example of all match. Boolean all start with A equal to names dot stream. All match of name implies names dot start with of A. This method, all match method, only collects the names whichever starts with letter A. Example of none match. Boolean none end with Z. Names dot stream, none match of names implies names dot ends with of Z. So if any name which is ends with Z, those list alone, matching list alone available inside the name list means just it is giving true. For example, find match, optional string of first long name equal to names dot stream. After creating a stream, name stream, dot filter of names implies names dot length greater than 5. The string which is more than 5 character alone filtered by the filter method, and dot find first method helps to give fetching the first string which is more than 5 character alone stored inside the first long name. The matching and finding operations are powerful tools for querying and extracting specific elements from a stream. Matching and finding any match, all match, none match, find first, find any. Test elements or find elements based on the predicate or conditions. Import java.util.list. Here public class match example is the class example, class name. Inside class main method, and after the After writing the main method, just creating a list integer type. List name is numbers equal to list dot of 1, 2, 3, 4, 5, 5 elements integer numbers stored inside the list. Boolean all even equal to numbers dot stream method to create the stream. After that, all match n implies n mod 2 equal to 0. Then only even numbers whichever matched in that particular number stream stored in the immediately it is anything matched, then it is telling that true. Then system.out.println is storing the boolean value whichever based on the predicate or condition, it is giving the boolean value true or false. Terminal operation counting. Count method is used in this example. Long count equal to names dot stream. After creating a stream dot filter, name implies names dot start with of letter A dot count. Here in this functional programming filter method we are applying to collect only the names whichever starts with the A letter alone collects, and the count is getting incremented if any names which are matching with the letter A. Count provides a way to determine the number of elements in the stream after applying filters. Discuss the performance consideration of counting in large streams. Highlight how counting can be used in combination with other. Count the number of elements in a stream. Import java.util.list is a package we included, and count example. Here this program counts number of elements in the number stream. The Stream API provides a rich set of operations that can be combined in various ways to process data more effectively. It promotes functional programming principles in Java and enhances the language's ability to handle complex data processing tasks with ease and readability. Thank you.